So now let's look at a little bit about send induction. So we have to consider a padlock which has a code to unlock it. So if we set the code to unlock this padlock as 4-digit numbers, 7351, then 3517 will not work to unlock it. So why is this happening? Because here the order of the number is important. Okay, so this is permutation where the order of elements is very important. Okay, so permutation of a set of objects is a arrangement of those objects in a definite order. Okay, so the key here is order is important. For example, if we have set A, B, C, and D, then AB is 2-element permutation of A. Okay, ACD is 3-element permutation of A. ADCB is 4-element permutation of A. Okay, so here the order is important. AB will not equal to BA, and so on. So the order in which objects are arranged is important. For example, AB and BA are considered as different 2-element permutation. ABC and CBA are distinct or different 3-element permutations. ABCD and CBAD are different 4-element permutations. So another arrangement of ABC, okay, so we can arrange ABC as ACB, BAC, BCA, CAB, and CBA. So they are all different permutation. So the number of permutation can be calculated by a rule called the multiplication principle. Okay, so multiplication principle states that if there are m ways for an event to occur, then and n ways for another event to occur, then there are m times n ways for the two events to occur. So let's consider an example. If there are 4 ways from Johor to Penang and 2 ways from Penang to Langkawi, in how many ways can we go for a journey from Johor to Langkawi through Penang? So let's look at this diagram. So we have 4 ways to go from Johor to Penang, which is by using taxi, bus, van or train. And we have 2 ways to go from Penang to Langkawi, which is by using flight or ferry. Okay, so to go from Johor to Penang to Langkawi through Penang, we can use multiplication rule, which is 4 times 2 equals to 8. So we have 8 ways to go from Johor to Langkawi through Penang. So that is what we call as multiplication rule. Now let's look at example 1. A coin and a dice are tossed together. How many different outcomes are possible? So the coin has 2 possible outcomes, which is head or tail, and the dice has 6 possible outcomes. So the number of possible outcomes is 2 times with 6, which is equals to 12. And the possible outcomes are, it can be either head and 1. Okay, head is from the coin and 1 is from the dice. Okay, it can be head and 2, head and 3, head and 4, head and 5, head and 6. And we can also have tail and 1, okay, tail and 2, tail and 3, okay, tail and 4, tail and 5, and also tail and 6. Okay, so that's how we list the outcomes. Or we can also use this way. Okay, we can build a table like this to see what is the outcome when we toss dice and coin together. Okay, next we look at the permutation of n objects. Okay, so let's consider the method for finding a number of permutation on letters A, B, and C. So we have 3 letters. So we want to determine how many arrangements of the letters A, B, and C are there, okay, without repetition. Okay, so let's consider of ways of arranging n letters. So if we have 1 letter, there is 1 arrangement. Okay, for example, it can be A. Okay, it can be B, or it can be C. Okay, so if we have 2 letters, we have 2 different arrangements. Okay, this is only example. We can have AB or BA, or maybe AC or CB. So we have a few different arrangements. Okay, if we have 3 letters, the different arrangements are, okay, so we can draw a diagram like this. Okay, for the first one, we have 3 letters, A, B, and C. Okay, so 3 ways. And then after we take out 1 letter, we still have 2 letters left. Okay, so we have 2 here. Okay, for example, if we take out A, we are left with B and C. Okay, if we take out B, we are left with A and C. That's why we have 2 letters. And for third letter, when we take out another letter from here, we only have 1 letter. And then we are going to multiply everything. So the answer is 6. Okay, so we look at example. How many different ways of arranging 3-digit numbers from digit 5 and 6? Okay, so first, repetition are allowed here. This is a very important information. Repetition is allowed. So if repetition are allowed, first we have number 5 and number 6. Okay, and then we still have number 5 and number 6 because repetition are allowed. And for the third arrangement, we still have 5 and 6. Okay, so we multiply everything. The answer will be 8. Okay, and then we look at how many different ways do you think there are of arranging 4 letters? Okay, you should be able to see 24 different ways. Okay, which is found from this. Okay, so to arrange 4 letters, we are going to multiply 4 times 3 times 2 and times 1. Okay, so if there are 500 different objects, okay, so the number of ways should be 500 times with 499, 498 until 1. Okay, so this will be tedious to write, very tedious and very long to write. So we use the notation 5 factorial, okay, to simplify the way to write it. So now let me introduce you to what is factorial. So factorial is given by this, and factorial is equals to n, okay, times with n minus 1, n minus 2, n minus 3 until 3, 2, and 1. So an important note here, 0 factorial is equals to 1 and 1 factorial is also equals to 1. Okay, so take note that if we have n factorial, so n factorial equals to n times n minus 1 factorial. For example, if you have 5 factorial, you can write it this way. Okay, 5 times with 4 factorial. Okay, or you can write it further, 5 times 4, and if you want to stop at 3, you have to put factorial here. Okay, so that is how we deal with factorial. So in general, the number of permutation of n different objects taken all at a time without repetition is npn, or equals to n factorial. Okay, so let's look at an example. How many 3-digit numbers can be made from the integers 2, 3, and 4? Okay, so here we have n equals to 3 because we have 3 numbers, 2, 3, and 4. Okay, so to arrange 3-digit numbers, we can use this formula, 3p3, which is equals to 3 factorial, or we can use multiplication formula, which is 3 times 2 times 1. So the answer is 6. Okay, or you can press your calculator right away. What is the answer for 3p3? Okay, so let's look at example 2. In how many ways can 10 instructors be assigned into 10 sections of a course in mathematics? So we have 10 instructors. So to arrange it to 10 courses, so we have to use this formula, 10p10, or equals to 10 factorial. Okay, so we can use multiplication principle. Okay, so 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 and times 1. Okay, so we are going to obtain the answer equals to 3628800. So now we look at example 3. In how many different numbers can be formed from digit 5, 6, 7, and 8 if the first digit must be 7, which no repetitions are allowed? Okay, so the first digit must be 7. So we have here 1p1. The first digit will be 7. So we have one number 7 and we select 1 and we arrange 1. And we multiply with the remaining number. We still have number 5, 6, and 8. So we multiply with 3 factorial. factorial here. Okay, so the answer will be 6.